What will astronauts eat on the way to Mars?
So, on the way to Mars, food becomes one of the biggest engineering and psychological challenges. Unlike the International Space Station, where resupply ships bring fresh deliveries every few months, a Mars crew will have no resupply for almost 3 years. Everything they eat on the journey, about 7 to 10 months, has to be packed, preserved, and ready before launch. NASA's plan is simple: use shelf-stable foods that last at least 5 years. These are mostly freeze-dried or thermostabilized meals stored in vacuum-sealed pouches. Think of dishes like beef stew, rice and vegetables, or pasta, dehydrated, then rehydrated using water aboard the spacecraft. Drinks will come as powders mixed with purified water, but bread will not work because of crumbs, so tortillas will be the bread of choice. But eating isn't just about nutrition, it's also about morale. Imagine eating the same textures for 200 days. That's why NASA's Advanced Food Technology Lab is developing a variety of strong flavors, spicy stews and sauces, because microgravity dulls your sense of taste. What?
Horrible, putrid, disgusting excuse for a sandwich it has ever been my displeasure to have slither down my throat!
Yeah, astronauts often say food seems like eating while you've got a stuffy nose. That's why hot sauces are favorites. They make things exciting again. And there is another frontier: space farming. NASA's veggie and advanced plant habitat experiments on the ISS proved that astronauts can grow lettuce, radishes, and even chili peppers in microgravity. On a Mars ship, small plant chambers could give crews occasional fresh produce, improving nutrition, and provide psychological relief. So astronauts on their way to Mars will not survive on pills or paste. Every bite is planned, because food isn't just calories in deep space. It's survival, health, and sanity. Next question.
How will astronauts sleep on the way to Mars?
On the way to Mars, astronauts will still use sleeping bags like on the International Space Station, but this time they will be inside small private quarters, designed to block out noise and light. With no day-night cycle, the ship runs on a strict artificial schedule. Lights dim and brighten to mimic a 24-hour rhythm. Without that, the crew's circadian rhythm will be off, leading to insomnia and fatigue. The circadian rhythm is the pattern your body follows based on an internal 24-hour day. This rhythm tells your body when to sleep and when to wake up. It also affects several other body processes, like your hormones, digestion, and body temperature. But sleep in deep space also has higher stakes. On the ISS, you can get by with 6 hours and still rely on mission control for backup. On a Mars ship, every decision rests on the crew.
Where have you been sleeping?
Airlock 2.
What?
Do you understand how crazy that is? If one seal breaks, you die.
Because Mars and Earth are so far apart, signals take several minutes to travel. Depending on their positions, it can take 3 to 22 minutes one way, so a round-trip message could take up to 44 minutes. What? Yeah, you send a signal and only after 44 minutes you will get an answer. So poor sleep means slower reaction times, more mistakes, and more conflicts. All risks that could be mission-ending. Radiation adds another complication. Cosmic rays may disrupt brain function, including sleep quality. And unfortunately, we did not study that as much as we should. So for long trips, researchers are looking at shielding sleep quarters with water or fuel tanks, doubling them as quiet zones for rest. So while sleeping in microgravity may seem simple, zip into a bag and float.
From now on, you sleep in Beck's room.
Where am I gonna sleep?
With Johansson. Cut it out, Beck. It's a small ship. I know everything.
On the way to Mars, it's about discipline, careful environment control, and protecting the mind as much as the body. because in deep space, even sleep becomes a mission-critical system. Next question.
How will astronauts handle microgravity on the way to Mars?
Living in microgravity isn't just strange, it's dangerous. On the way to Mars, astronauts will spend more than half a year without gravity pulling on their muscles and bones. Without constant exercise, their bodies would weaken dramatically. That's why a spacecraft will carry specialized exercise machines, treadmills with harnesses, resistant devices that use vacuum cylinders instead of weights, and stationary bikes. NASA already tells astronauts to work out at least 2.5 hours every single day on the ISS, and Mars crew will need the same discipline. But even with exercise, microgravity causes strange effects. Fluids can shift upward, your face can puff up, and legs can shrink. Many astronauts say it's like having a permanent head cold, but more seriously, blood pressure in the skull can rise, pressing on the eyes and even changing vision, a condition called spaceflight-associated neuroocular syndrome. For decades, one proposed solution was rotating spacecraft to simulate gravity using centrifugal force, but recent studies have shown that this might cause more harm than good, that we know of. The problem is that spinning sections create uneven forces inside the body. Astronauts might experience dizziness, motion sickness, and even damage to blood vessels in the brain. Researchers now believe that rotating habitats, unless built on a truly massive scale, could introduce serious medical risks instead of solving them. So for now, Mars crew will not rely on gravity wheels or spinning sections. Their survival will come down to exercise, strict medical monitoring, and daily routines that keep their body as strong as possible, even while floating weightless for months on end. Next question.
How will astronauts be protected from radiation on their way to Mars?
On Earth, we're protected by the atmosphere and magnetic field. In space, astronauts are exposed to galactic cosmic rays and bursts of solar radiation. A Mars trip is especially risky. A round-trip mission could expose crews to radiation equivalent to thousands of chest X-rays that we know of. NASA's plan is layered shielding. The spacecraft's wall will be lined with materials like polyethylene or water, which are good at absorbing high-energy particles. Critical areas like sleeping quarters may be surrounded by water tanks to create a radiation storm shelter. If a solar flare erupts, astronauts will have only tens of minutes to move into these shelters. NASA has simulated this. Astronauts will hunker down in the shielding section for hours or even days, surrounded by supplies that block radiation. But long-term radiation is the single greatest medical risk for a Mars mission. It increases cancer risk, damages the nervous system, and may even affect your cognition. That's why both NASA and European Space Agency are experimenting with new materials, drugs, and even magnetic shielding concepts. So radiation will not stop us from reaching Mars, but it's a constant invisible threat that will shape how spacecrafts are built and how we'll cruise, live inside them. Next question.
How will astronauts communicate with Earth on the way to Mars?
Radio signals and soon laser beams carry messages back and forth, bouncing off giant antennas of the Deep Space Network. At closest approach, the delay is 4 minutes. At farthest, it's 22 minutes. That means no real-time conversations. No, Houston, we have a problem. Only send, wait, and hope your answer comes back in time. For crews, that delay changes everything. Quick fixes from Earth will not be possible. Astronauts must be more autonomous, solving problems on their own. To cope, the crew on Earth use a mix of communications, emails, recorded messages, and schedule live conferences, with patience for pause. In daily life, astronauts will do regular video calls with family and broadcast science updates, but they will always remember that any reply from Earth will come with a significant lag. Future missions will use high-bandwidth laser links to transmit science data and even video, but the delay will always remain. Talking to Earth from Mars is like sending letters across the entire solar system with light as your postman. Next question.
How will astronauts manage waste on the way to Mars?
In space, waste management is as critical as oxygen. Urine and even moisture from the air are captured and turned back into drinking water. As NASA likes to say, yesterday's coffee is today's coffee.
Yeah, sure. Whatever.
The solid waste is different. The toilet uses suction fans to pull it away into sealed containers. Those containers are stored until they can be disposed of. On ISS, it's usually by packing them into cargo ships that burn up in Earth's atmosphere. As for fertilizer, direct use of raw human waste is too dangerous. It carries bacteria, pathogens, and even antibiotic-resistant microbes. On the way to Mars, there won't be the luxury of fully processing it into, say, fertilizer inside the ship. Researchers, they are exploring bioreactors that could break it down into usable compounds. That technology is still experimental though, but on the surface of Mars, things change. Once habitats are established, human waste could be treated, composed and used to enrich Martian regolith for growing plants, but only after a thorough sterilization. NASA has already tested systems that can convert waste into methane fuel and nutrient-rich byproducts that could be valuable on Mars. For a Mars mission, every gram matters. Systems are being designed to recycle as much as possible, even turning waste into useful resources. In space, there is no such thing as throwing something away. Everything gets a second purpose. Next question.
What happens if there is a medical emergency on the way to Mars?
On the International Space Station, if something serious happens, astronauts almost always can jump into a capsule and be back on Earth within hours. On the way to Mars, that's not possible. You are months away from home. That's why crews are trained extensively in medicine. They will have supplies for surgery, diagnostics, and a wide range of drugs. Some astronauts will be cross-trained as medics, and with AI-guided tools, they will be able to handle emergencies more independently. But still, they will consult Earth doctors, but with a 40-minute delay, real-time guidance isn't possible. Prevention becomes the top goal. Strict health checks before launch, constant monitoring, and careful protocols to avoid accidents. If it were life-threatening enough, mission planners would have to consider turning back, but everything possible is done so that doesn't happen. In deep space, the crew has to be its own hospital. Next question.
What if someone died on the way to Mars?
That's one of the most difficult but important questions about a Mars mission. On the way to Mars, there is almost no return option. NASA and European Space Agency have studied this scenario. The first priority is the health of the living crew and preventing biological contamination. A deceased astronaut would need to be placed in a sealed body bag or a container to isolate it from the rest of the habitat. Some concepts suggest body freezing, storing the remains outside the ship, exposed to deep space, essentially using space as a freezer.
2,000 years later.
Another idea called body bag, proposed by a company working with NASA, involves a pod that would freeze dry the body using vacuum, then reduce it to sterile powder for compact storage. That way the mass is preserved, but the risks are minimized. Burial on Mars isn't likely in early missions, the Martian soil isn't sterile, and introducing human remains could contaminate scientific studies of potential Martian life. Planetary protection protocols are very strict. Nothing biological can be casually dumped on the surface. It is a grim subject, but NASA's philosophy is clear: preventing comes first. But if the worst did happen, the crew would be prepared with strict procedures, protecting the mission, the science, and each other. Next question.
How will astronauts maintain mental health on the way to Mars?
Imagine months in a small ship, cut off from the world, with the same crew every single day. Mental health is just as critical as physical health, and they will have to manage stress largely on their own. Astronauts will rely on strict routines: exercise, work shifts, shared meals, and designated downtime. These structures keep the body clocks stable and prevent the drifting sands of timelessness. They will also have access to digital support, like pre-recorded counseling sessions with psychologists and personal messages from family. But the communication delay means they cannot just call home when things get hard. In the Mars 500 experiment in Moscow in 2007, 6 volunteers lived for 520 days in a mock spacecraft, completely isolated, with delayed communication. They reported mood swings, conflicts, and boredom, but also that structured routines, team bonding, and regular tasks helped them stay sane. The high seas habitat in Hawaii tested crews living on a Mars-like volcano cut off for months. One major finding: crews need private space to retreat when tension rises. For a Mars trip, mental health will be protected by giving astronauts a balance. Time for science and mission goals, shared meals, hobbies, personal reflection, and group activities, even movie nights. Because in deep space, mental resilience is a life support system. Next question.
What will astronauts do if something breaks on the way to Mars?
On the International Space Station, if a system fails, ground control in Houston or Moscow can walk the crew through the repair step by step. But on a Mars mission, real-time troubleshooting isn't possible. The crew will need far more autonomy. NASA and European Space Agency are already preparing for this. Crews will train like spacecraft mechanics, learning how to repair everything from life support filters to electronics. The ship will likely carry 3D printers to make replacement parts out of plastic or even metal powders, reducing the need to stock every possible spare. Experiments on the ISS have already proven this works. For major systems, redundancy is the rule. 2 or 3 times backup so that a single failure doesn't end the mission. For example, water recycling, oxygen generation, and propulsion will have multiple layers of backup. Earth-based Mars simulations showed how crews handled unexpected breakdowns in isolation. They found that problem solving together, even under stress, strengthened teamwork and gave astronauts sense of control. So what happens if something breaks on the way to Mars? The crew repairs it themselves. Failure isn't an option, because in deep space, survival depends on being your own engineer, doctor, and mechanic, all at once. Thank you for watching. Don't forget to subscribe and share your thoughts down below.